Tableau 2, Part 2. Basic Properties of Binomial Coefficients. Now, you might have wondered when you saw our definition of a binomial coefficient that this wasn't quite the form that you saw it in high school. It is useful for such an elementary and important object to look at it from several different vantage points and to discover structure and properties. So this is what our tableau is going to be about. So we begin with an alternative form for the following factorial. The motivation here is that the following factorial is a key component in the definition of the binomial coefficient, and therefore it behooves us to look at it a little bit more carefully to understand its mathematical structure. Accordingly, let's begin with n to the k falling. Recall that this stands for the number of distinct ordered samples of size k that we can engender from an underlying population of size n when the sampling is without replacement. Now, by definition, this gives you a product of k successive terms starting at n, each term one less than the previous one. Excellent. We call this the following factorial. Now, it looks like a factorial, but of course it is not quite a factorial. So what if we go ahead and complete the missing terms? Now, the terms that are missing are the expressions n minus k minus 1, n minus k minus 2, and so forth, all the way down to 2 and 1. If you multiply all of these in the numerator, we will get a bona fide factorial. But we can't simply multiply numbers, can we? We're going to have to properly normalize by dividing by the same quantity to keep our identity honest. So let's write down the next step. We simply put in all the terms that are missing from 1 till n minus k in the numerator and in the denominator. Pause for a bit and write it down. Remember, learning mathematics is an intrinsically tactile endeavor. You write, you think, you pause, you think again, write, think, read, in the words of Alan Turing. Now, when you're ready, restart the lecture. Now, as you progress, what do you say? Well, in the numerator, we've got a factorial. We've got all the terms from 1 till n. Of course, that gives us n factorial. In the denominator, we have all the terms from 1 through n minus k. We have n minus k factorial. And now we've discovered an identity. N to the k falling is nothing more than n factorial divided by n minus k factorial. Excellent. Let us quickly test our understanding. Evaluate, express n to the n minus k falling in terms of factorials. Pause the lecture, see if we can work it through, restart when you are ready. Okay, now we are back. N to the n minus k falling is a falling factorial, and therefore, if in the previous expression we replace k by n minus k, we will get an identity. Well, this is easy. Let's go ahead and do this. N to the n minus k falling, then, is n factorial, and in the denominator, you subtract n minus k from n and take its factorial. Or in other words, you get n factorial over k factorial. Excellent. Now we've come to a right understanding of what exactly this falling factorial is and where the factorials come into play. Now let's leverage this understanding and move on to the binomial coefficient.